Let us introduce the standard work procedure of sun-earth type M5C used for grounding works. Before actual grounding work, solid and exact design work is vital and important. Once the grounding site is selected and requested grounding resistance is decided, first of all, measure the ground resistivity of the work site. Using Werner's 4-electrode measurement method, the result is used to calculate the construction length of sun-earth grounding. If the design work in this way has been completed, the site grounding work will be next. Let us look at the grounding work of the work site. Firstly, dig a trench with width more than 50 centimeters and depth 75 centimeters approximately. This can be done manually or by machines utilizing backbore where the work site permits. In either case, the plane level as flat as even as possible. After that, lay the grounding copper wire in the trench. About 22 square millimeter size is sufficient. Lay the wire by holding the wire roll so that the wire lies straight at the center of the trench. Next is sun-earth laying work. Place sun-earth type M5C along the trench at 3-meter intervals. Cut the bottom of the bag by cutter knife and while dragging along, shake off and spread evenly into the trench. A 25-kilogram bag is good for about 3 meters laying work. Furthermore, since it will overspread while laying, it will be good to carry it out against the wind. Next is step and hardening by foot to force out air in sun-earth. Firstly, pick up the laid grounding copper wire, use both feet to step and harden so that the center part between the feet becomes higher, and the wire fully packed and covered by sun-earth. Furthermore, it's more effective to carry out this process after every 2 bags, 6-meter interval before sun-earth absorbs soil water and becomes hardened. After the stepping and hardening process, cover back the dark soil into the trench. In the beginning, cover back the dark soil which does not mix with stone from both sides of the trench gradually. The copper wire should not be left visible above sun-earth when covering back the dugout soil. Then step and harden it. Different from other resistance-lowering material, the grounding resistance can be measured at this point of time. After that, cover back the rest of the soil, step and harden firmly, and the process is finished. After finishing the process, the measurement of grounding resistance comes next. Confirm whether the expected value can be obtained or not. Use the normal portable grounding resistance tester for measurement. This is called 3-electrode method. Extend the measurement wire in opposite to the sun-earth laying direction or at right angle to it and measure. The above-mentioned procedure is sun-earth type M5C standard work introduction. Let us introduce the strong point of sun-earth grounding material. As you can see from the grounding work procedure, sun-earth type M5C is used as powder form and lay in belt shape during works. Low grounding resistance can be obtained from good contact of wide surface area with the earth. Furthermore, water is not necessary during grounding work. It is more suitable for mountainous or remote areas where secure supply of water is very difficult. In areas which have roots after felling or lumbering, rocky projection from the ground, grounding works will not be hindered and therefore great saving in labor is possible. For metals laid underground, there will be electrolytic corrosion due to earth's stray current and the metal will corrode. As illustrated in the diagram, average current of 60 ampere flows for a 75-day period in the experiment circuit to compare the corrosion situation. This is to confirm the electrolytic anti-corrosive effect of sun earth. As you can see, the wire covered by sun earth is not corroded. However, the bare grounding copper wire is corroded and became tattered and ragged. If underground metal is completely covered up by sun earth, electrolytic corrosion can be prevented, and disconnection or breaking of wire due to grounding electrode corrosion can be avoided. Sun earth is a very chemically stable material, which means that chemical changes like dissolution or electrolysis under the ground will not take place. Therefore, it is a grounding material which does not cause environmental pollution and can be used extensively without worry at farms, clean water pipes, fishery farms, etc. When performing grounding works, we must bear in mind one important thing. When lightning surge current flows into the ground electrode, the characteristics of grounding resistance is different from normal grounding resistance measured by AC current. The characteristics of this lightning surge current is called grounding surge impedance. In this diagram, comparison of grounding surge impedance between sun-earth grounding and grounding copper wire deep grounded electrode of 40-meter work length is shown. It can be seen that deep grounded electrode by a process called boring process compared to sun-earth electrode, grounding surge impedance is higher for the period up to about 3 microseconds. This indicates that sun-earth grounding is the most excellent grounding for protecting low withstand voltage equipment like computer from lightning surge current. For the purpose of lowering grounding resistance, conductive material for lowering resistance use are electrolytic material type, which use chemical material, and conductive material type of resistance lowering material like sun earth. The diagram shows the comparison of grounding resistance changes in a 10-year period. Let us introduce a few grounding work examples which have special features and have adopted the landmark conductive material for lowering resistance to grounding sun-earth type M1C. It is clear that the grounding resistance of those structural buildings built by steel reinforced concrete, like the groundwork of huge buildings or steel tower, overhead bridge, overhead railway bridge, etc. It is much lower than the grounding resistance of normal grounding works. This is due to the structural building's groundwork foundation, which has a large contact area with the earth. For these low grounding resistance structural building, the use its structural steel as grounding electrode and connected to grounding wire is called structural body grounding. However, the concrete cannot be destroyed for connecting the structural steel in it to grounding wire. In that place, we have the plaster process using sun-earth conductive cement as the solution. Well, let us introduce the work example on overhead railway bridge. First of all, clean the work surface well with water. Add water to sun-earth type M1C type and knead together, creating a suitable hardness for sun-earth conductive cement. After laying the 22 square millimeter conductive wire to the work surface, cover completely the wire with sun-earth conductive cement. In this case, level the wire for smoothing iron so that sun-earth conductive cement thickness is about 3 centimeters. For the drawn-out part of grounding wire, bury the insulation sheath more than 15 centimeters inside sun-earth conductive cement. Use a plasterer's iron to poke well and force out the air inside. Finish with making the surface level and even. 30 to 40 minutes later, when the water on the surface has reduced, apply normal cement about 3 centimeters thick on top for protection. That is all for grounding work of structural building. Intelligent building, which is a symbol for highly information-oriented era, there are many types of equipment being installed, including DA equipment like communication equipment, building management system equipment, etc. There are many power supply equipment and facilities for these equipment, and many of them require proper grounding work. The grounding for intelligent building has an extremely important role to ensure all the electronics equipment can operate stably to display the highest function of the building. This type of building requires better grounding than normal grounding. Therefore, it is necessary to perform grounding work first during the stage of foundation work. As an example, let us introduce a radio station building's grounding work combined with radial earth using sun earth. After finishing the soil hardening of work ground surface, lay grounding copper wire in mesh net shape. Place the wooden frame and sprinkle water, and then follow by laying sun earth and bundle up the ground wire. Sprinkle water gently to prevent sun earth from scattering all over will also help to improve hardening process. This is the end of grounding work and foundation work begins. Grounding work shift to the next section in order. The section with completed grounding work will begin construction of ground beam. The above is an example of sun earth mesh grounding work basics for building. Grounding electrode made from sun earth conductive cement is strongly anti-corrosive in characteristics and therefore will not corrode even when used in seawater. In this way, it is being used in electrolytic anti-corrosion in telecommunication grounding for Tokyo monorail or Kanmon tunnel, and also as force current plus electrode buried at coastal area, etc. It is used extensively in electrolytic anti-corrosion. As mentioned in this above introduction, other than common use grounding, sun earth grounding is the material which can be used in extremely wide area of grounding process like mesh earth of power station or substation, steel tower foundation or railway overhead bridges, structural building grounding of structural building intelligent building, and also electrolytic anti-corrosion in seawater. Through the landmark conductive material for lowering resistance to grounding, sun earth, which is being used for protecting equipment and important human life in grounding technology, indispensable to the information network of 21st century. Sankosha has achieved further contribution to system security and progress of society.